So we are back again with another problem. This is again a problem from Microsoft series since we are doing the Microsoft series, and this is actually a binary search tree problem. If you don't know what is a binary search tree, this is a tree in which it can have at most two leaf nodes, and the left would be always less than the root node, the right would be always greater than the root node, and that this property applies at every leaf and every root. If you go like if you consider this whole, all the values would be less than the 6. If you consider this whole, right, all the values will be greater than 6. Any node it will apply, like this node 7 is less than 8 and 9 is greater than 9. This is a binary search tree. What is the lowest common ancestor? So it's defined between two nodes P and Q, means you will be given two nodes, and the lowest common ancestor to node T, that has both P and Q as descendants. So you will be given two nodes and you need to return a node, a lowest node that has both of the nodes as descendant. A node can be descendant of itself as well. So suppose you are given 2 and 8. So what is the least node that has both 2 and 8 as descendant? 6 is the least node, right? That both has 2 and 8 as a child or descendant, right? Similarly, like if you go for 2 and 4, there is a node that a node can be descendant of itself. So then 2 is the least lowest common ancestor that has both 2 and 4 as descendant, right? If this condition should not have given, then 6 would be the answer. If suppose 4 and 7 is given, right? So the 6 is the node that has both 4 and 7. So this is a simple problem. If you see the catch here, it's we will whatever your answer is, whatever is the lowest common ancestor is, that will fall in this range only. Like it will be from 2 and 8, the 6. Similarly, if you see this right, your answer would fall in this range only, 2 and 4. It would be like greater than or equals to greater than or equals to 2 or less than or equals to 4. What we can do, we can just pick a route, traverse it recursively from like top to bottom, and whatever the first node that is satisfying this property, right, that is in between this range 2 and 8, that would be our answer, because we'll go from top to bottom. So whatever the first node we will encounter, that would be our answer. So fine, like we can traverse this tree easily via recursive function. So what you can do, you can just first write a helper function that will again return a tree node that will take your root, that will take a minimum so far and the maximum so far, right? Because that's how we'll compare. Now we need to write a base condition. Every recursive function has a base condition. Here we can apply the result, like whenever we got a result, we can just return from this, we can just break from this recursion. So when we got the result, as I explained, right, if our current value is falling in between the range, right, in between min and max, right? So if your root dot value is greater than equals to min, greater than equals to is because just like the node can be descendant of itself, right? Because of this condition, we are considering equals to as well, and your value is less than equals to max. This is the condition, means we got our answer. Just return the root. If it is not the case, means we need to traverse the tree either on the left side or either on the right side. That depends on either our value is greater than min or less than the min, or like the vice versa. So if your root that value is greater than the max, right, means your uh, value is more. So you actually need to go to left side. You just need to bifurcate the right side. So just call this function recursively with the left side. If not, then the vice versa, like if the root dot val is less than your min, means you just need to go on the upper bound, right, on the right side. So you just need to call the helper function again, and call the right side of the tree. So till this point, actually, you will be here somewhere, like in the recursive call. You won't go till here, but actually this is you are returning something. So you just need to return something for the sake of it, and we can just return null. But actually this won't appear because like in any of the three conditions, your flow will get cool. Now you just need to call this function with the minimum from P and Q, whatever the minimum from P and Q and whatever the minimum maximum from P and Q, you can just call this function. So first get the minimum. So you can use math.min from P and Q. Similarly, get the maximum from this two. You can apply any condition, like you can check if and else also, just to get the minimum maximum. That is also fine. I just applied this, that comes first in my mind. Anything is fine. Now we have minimum maximum, right? Now we can call this helper function or just return whatever it is returning. So return your helper, just pass your root, your min and your max. Just run this. Compilation error, your root, some typo, 25. Code. This is finished. This is the, I think your answer is 2 and the accepted answer is 6 for 2 and 8. Okay, so we have some live debugging here. So what we are doing wrong, minimum is your p dot val, q dot val, maximum is your p dot val. Okay, we apply min again, so this is max. Now it's fine, right? Let's test for all the cases. So this is accepted. Cool. Thanks.